Hello and welcome to my first lecture, the Calculus 1 lecture, which is going to be taught to be easy, and it's going to be very quick, much like Crash Course. Anyway, without further ado, let's get going. Calculus 1, Unit 1, Pre-Calc Review. Point slope form. Y equals mx plus b with rise and run, delta x change in x over delta y change in y. That's what the delta means. Absolute value, all values positive regardless of sign. Polynomial degrees. Raised to the second power, second, raised to the third, third, raised to the fourth, fourth. Raised to the nth is the nth polynomial degree. Exponents and logarithms. A to the x is exponent. Logarithm x to the b is log. Equals a is log. So you can raise a number to a certain power. That power is the variable, unlike a polynomial where the variable's on the bottom. Logarithm is the inverse of the exponent, much like how division is the inverse of multiplication, same thing like subtraction, addition. ln is natural log, 1 over e. E is the inverse natural log. Now that we've gotten past Unit 1, let's move on to Unit 2. Functions. F of x, that's how you say functions in algebra and calculus. Function of x. Example, f of x equals x squared. F of 1, 1 squared equals 1. F of 2, 2 squared equals 4. That's a parabola. F of g of x composite function, which has the chain rule. H of x. Chain rule, do what's inside first. Working way out. Unit 3, limits and continuity. The limit of a function is when its continuity ends. Continuity is when a function does not exist, DNE. You'll learn about that later. F of x equals x squared. Limit of x squared to the 4. The limit would be 2 because it's 1.9, 1.99, 1.999, so you get infinitesimally close to 2 on the minus side. Here's another one for a trig function. Limit of sine to the pi on the plus side. 90 degrees, 0.1, 0.01, 0.01, it's 90, because, meaning like it's pi. And that was Unit 3. This is a much longer unit, so be patient. Unit 4, differential equations. D over dx is not a fraction. Differential equations of polynomials. D over dx of x squared is 2x. You're basically decomposing the polynomial. 2x squared, 6x squared. 2x third, 6x squared. 2x to the second, 3x. Plus 3x, I mean. That's a two-parter. Do each part. Each part to the polynomial. 4x plus 3 as a result. Derivatives of radicals. This is radical. D over dx of rad x. X to the 1/2 is what it really is. X to the negative 1/2 because you're taking away 1 degree. 4x squared. 4x 2 times 1/2. 4x to the 1. That means it's 4x, simply. D over dx, 4x equals 4. D over dx, xx equals 1, so d over dx 1 equals 0. When you're doing constant, that just makes it a 0. It's part of the heat equation you'll learn later on. d over dx cubed root of 9x, 9x 1/3, 9x negative 2/3 as a result. The tangent and secant lines. Secant lines show like going through the middle of the lines, whereas tangent lines ride on there like a roller coaster onto polynomials, and that's where derivatives of sine and cosine functions come into play. When you're riding on the tangent line, you get to the one place, and that's where you get the derivative on one of the 4 sections of a sine or cosine wave. Derivative of a sine equals cosine, cosine equals negative sine equals negative cosine equals sine, and back around. It's the unit circle clock, just like the I clock for imaginary numbers. It goes around and around and around. Continuing, derivative of the other trig functions. Tan equals secant squared, cotan equals cosecant squared, secant equals tan x, secant x, cosecant x equals cotan cosecant. Derivatives of exponents. Dx, d over dx, ax equals ln a ax. Just multiply by ln a. Then e to the x ln a du dx eu du. Has to do with another thing called u substitution, where you're substituting for u. Examples: 3 to the dx 3 to the x equals ln 3 to the x. 10z to the x ln 10z to the x. That's a multi-dimensional one with 2 variables. Learning later about in calculus too. So, and the natural log is what it is. All about, like, inverse of e. Derivatives of rational equations. 1 over x equals 0, because x equals 1 equals 0, so it's 0 over 1. And x can equal 0 if it's in the denominator. X over x squared, 1 over 2x, because you're taking the derivative of x and derivative of x squared. 2x minus 1, x cubed minus 2x plus 3. That's a big one. 2x minus 1 equals 2, 3x squared, and then x to the cube, 2x plus 3, 3x squared minus 2. Yeah, higher order derivatives finally for this unit. X to the 4th, 4x cubed, x to the 4th, 4x cubed, 12x squared, then of that it's 24x, then 24, 0. You're just dissecting that polynomial. Then d over dx radical x dx, d over dx, x to 1/2, then it's x to the negative 1/2. Then you take the second derivative of that, and you get x to the negative 3/2. Then the third is x to the negative 5/2. Okay, integration. Capital F of x is what you use for integrals. Lowercase f for differentiation. We'll go over that geometric part soon, but I'm going to first go over indefinite. It's like x squared over 2 plus c is the answer to x, because you need to add the c to the end and put it over the power. Same thing with that one. The x squared, x to the cube over 3 plus c, cosine plus c for negative sine integral, rad x, x to 3/2 over 3/2 plus c. Indefinite, you go from a to b, and here it is. You're finding the geometric area. It's just basic geometry, finding the area under the curve. This specific one is x squared. So find the areas of each integrating by parts. 0.7, 1.0, 4.2, 4.0, that adds up to 7.9, whereas you take off the 4.0 part of it to add on the lower spectrum, 3.9. In between is where the answer lies. Then, for sine, you add 0.07, 1.0, multiply them by 2 each, and then you get 3.4 for like 0 to 90 degrees, 0 to pi. However, when you're doing a sine, cosine, cosecant, or secant function, then you're doing 0 to 2 over pi, or no, 0 to pi 2, or 2 pi. It cancels it out. Unit 6, sequences and series. Sequences, example, S sub 1 is 1, 3, 5, 7, 9, for like the S subs. All odds, 1 and greater. Limit n to the positive infinity. Sequence series. You have this sigma notation where the n goes on the bottom, and positive infinity on the top for this specific one. S to the n. S sub n, I mean. Now, geometric series, you have these as an example, because it goes constantly until you get to n, the powers. You also have this one, 1/2, 1/4, 1/8, 1/16. Sigma 1/2 n minus 1. Alternating series. The harmonic series, you go from plus to minus alternating, and that's how it diverges, like that. And that's it for Calculus 1.